Welcome everyone. So this is Intermediate Algebra. I'm Professor Adamick, and so I hope you enjoy this journey. So we're going to start by solving systems of linear equations. And so I'll start by just reminding you of what is a linear equation. So there's several ways of writing linear equations. One way is this way. We have ax plus by equals c, right? So this is sometimes called the general form of a linear equation. So here a, b, and c are just real numbers, right? So a, b, and c are just numbers. And a and b cannot both be 0. So a and b are not both 0. There we go. Right, and c could be 0, right? And either a or b could be 0, but not both, right? Right. So a good example of that might be, 3x minus 4y equals 8, right? So a is 3, b is negative 4, and c is 8, right? So this is one example of a linear equation. Another way you can write it is in the form y equals mx plus b, right? So lowercase b, not uppercase b, different b. And you should also recognize this as the slope y-intercept form. Y-intercept form, right? So here m is a number, right? It's just the slope. Hopefully you know what that is. It's, the usual rise over run, right? So we're not going to get into that. And b is the y-intercept, or specifically the point 0b, right, is the y-intercept. So if you were to graph this line, it's where the line crosses the y-axis, right? Okay, so an example of that would be, say y equals 2x plus 5 over 3. Right. So yeah, they don't have to be nice whole numbers. They could be fractions, decimals, all that. Any real number. Right. Yeah. So those are linear equations, right? So a system of linear equations is just two of these, right? So you can say these two form a system of linear equations, right? Of course, you can have a system of 3 or 4 or 5 linear equations and so on, but we're going to concentrate on just 2 at a time, right? So our systems are going to be 2 equations in 2 variables, x and y. Okay, so here's our first example of a system of 2 equations in 2 variables. We have the equation y equals negative 2x plus 11 and 3x plus 2y equals 14. So those are 2 equations. I tend to label them as, say, equation A and equation B. You can call them 1 and 2, or just have different labels so we know which one is which, right? And then we can talk about the solution to this system. A solution is just an ordered pair of numbers, right? By ordered pair, I mean 2 numbers, right? A solution is not a single number here, right? It's a pair of numbers. It's an x and a y, right? The x always comes first, and then the y, right? And keep in mind that we won't always use x and y as our variables. We can use different letters like a and b, or r and s, or w and t, right? But most of the time it'll be x and y, so we'll stick with that for now. Right? And in this case, the solution is the particular ordered pair 8, negative 5. Okay? Now, how do you get that? Well, that's the hard part, right? That's something we're going to get into very soon. That's something that you're going to have to learn how to do, right? That's kind of the whole point of this topic here, right? So we're going to have to solve this system, right? By solving the system, we end up with the solution. Right? And this is going to be kind of a long and tedious process, but we'll get through it, right? And it's really not that bad. right? Once you learn how to do it. And again, for some of you, this may already be familiar. Some of you may know how to do this. So if it's review, then you can quickly go through this. And if this is new to you, then you might want to spend some more time on it, right? Okay, so before we get to how do we actually solve the system, and again, I think my a little sloppy here. So you solve the system and you get this, right? So we'll get to that in just a minute. First thing we want to do, though, is, right, how do you know that this is actually the solution, right? Don't take my word for it here. Check yourself, right? So we want to check that this ordered pair, x equals -5 and y equals, x equals 8 and y equals -5, right? So x equals 8, y equals -5, that this is indeed the solution, right? So how do we check that? Well, you check it just by plugging in the numbers, right, into the equation. Everywhere you see an x, change it to an 8, and everywhere you see a y, change it to -5. So let's start with equation A. Equation A is y equals -2 times x plus 11. So if I replace y with -5, and I replace x with the number 8, is this true? Right? Does 5 equal -2 times 8 plus 11? Well, let's see, right? So -5, there's nothing we can do with that. It's -5, right? But on the right side of the equation, we have -2 times 8. -2 times 8 is -16. And -16 plus 11, right? Or if you prefer, 11 minus 16 is indeed -5. So what we end up with is the equation -5 equals -5, which of course is true, right? -5 is the same number as -5, right? So equation A is correct, right? I kind of scrolled up here. Equation A is correct, right? What about equation B, right? Because you have to check both. So equation B was 3x plus 2y equals 14. Okay, so again, we're going to replace x with the number 8, right? Because that was our solution. That was part of the solution, right? And we're going to replace y with the number -5. So the question is, does that equal 14? Well, let's multiply this out. 3 times 8, right, is 24. 2 times -5 is -10. Okay, so does 24 minus 10 equal 14? 24 minus 10 is indeed 14. So that's also true. And so now we checked equation A and we checked equation B, and they're both correct. So that's how we know for sure that this is our solution. Okay. So this is something you should do every time you solve a system of equations, is just take the numbers, plug them back into both equations, and check to see that those equations are true, right? So what happens if it wasn't the solution? Well, then you might get something, you might get an equation, something like 3 is equal to -17. Well, 3 does not equal -17, right? This is false. So if you get something like this, you know that it's possible you did something wrong, right, when you solve the equation, right? Or it's also possible that you didn't do anything wrong, but that the equations might not have a solution, and we'll talk about that a little bit later. Okay, so that's checking a solution. Now, how do we actually solve the equation to get the solution, right? And it turns out there's several ways of doing it. We're going to start by using what's called the method of addition. Okay, so first way is the method of addition. Other books call this the method of elimination. And we'll see in a minute that it's really both, right? So the method of addition, also known as the method of elimination. Okay, so I'll take you through this step by step, right? So here's our system. Y equals -2x plus 11, and 3x plus 2y equals 14. Again, I'll label the first equation as equation A and the second equation as equation B. All right. And so we want to rewrite both, step 1, right? We want to rewrite both equations in the form ax plus by equals c, right? And you'll notice that the second equation, equation b, is already written in that form. 3x plus 2y equals 14, right? Because this is ax plus by equals c. A is 3, b is 2, and c is 14, right? However, the first equation is not in that form. The first equation is in the form y equals mx plus b, right? Which is also an acceptable form, but not if you're solving the system using the method of addition. Okay, so the first step is, how do we rewrite this equation, y equals negative 2x plus 11, in the standard form, or the general form, ax plus by equals c. Right, so notice that in this form, the x and the y are on the same side of the equation. Right? In this form, the y is on the left and the x is on the right. So what we really need to do is bring the x over to the left side. Right? So how do we do that? Well, use the golden rule of equations, right? Whatever you do to one side of the equation, you have to do the same thing to the other side. So if I want to get rid of this negative 2x on the right side, I have to add 2x to the right side. But if I do that to the right side, I have to do that to the left side as well. Right? And so now the left side becomes 2x plus y equals negative 2x plus 2x is 0, right? 0 plus 11, which of course is just 11. Oops. Right? So there's equation A, right? But now it's in the general form. It's in the form we want, right? So we can rewrite this in the form 2x plus y equals 11. And the second equation we can leave alone. 3x plus 2y equals 14. Okay, so there's our system, right? And notice that everything is lined up, right? The x's all have their columns here. These are the x's, these are the y's. And then on the other side, you should, oops, sorry about that, you should just have numbers. Okay? And that's a 14 here. So, all right, so bear with me. The system tends to do this, wiggle it around every once in a while. All right, so that was just step one, right? We rewrote the equations in standard form. All right, so step two says we need to choose a variable to eliminate. So we can choose x or we could choose y. And it's really up to you. So here's our step two now. Right, so do we want to eliminate x or y? Well, again, it depends on what you think is easier here. All right, our goal in step two is to essentially eliminate either x or y. And that's why this is also called the method of elimination, right? So what we're going to do, right, and this is where, right, step two is kind of tricky here. It's to find the same coefficient for x or y, right? So if we want to eliminate x, we have coefficients of 2 and 3, right? And so if we multiply 2 times 3, we can get 6. And so what we want to do is change both of these coefficients from 2x to 6x, right? And then have one of them be negative, right? So one of them will be positive 6x, the other will be negative 6x, and then when we add those, we get 0, and that eliminates the x. Got it? So let's do that, right? So let's take the first equation, equation A, right? In its standard form is 2x plus y equals 11. And somehow we want to get this 2 to be a 6. So we can do that as long as we multiply by 3. Right? 3 times 2 is 6. But if I multiply the left side by 3, I have to multiply the right side by 3 as well. So now 3 times 2x is 6x, right? Plus Don't forget the distributive property, right? You have to multiply 3 times y as well. And then on the right side, 11 times 3 is 33, right? So this is still equation A. We just multiplied it by 3. Got it? All right. Now let's do the same thing with equation B. Equation B was 3x plus 2y equals 14. Okay, and again, we want this 3 here to become, in this case, a negative 6, right? Because we want to cancel the positive 6 here. Okay, so 3 times what is negative 6? Well, negative 6 divided by 3 is negative 2. So multiply both sides by negative 2. Got it? And if we do that, negative 2 times 3x is negative 6x, as promised. And then negative 2 times 2y is negative 4 times y. And then on the right side, 14 times negative 2 is negative 28. Okay, so this is also just equation B rewritten. All right, so right, it's a little bit tricky to see them side by side like this. I would prefer to write them vertically, right? So equation A, again, 6x plus 3y equals 33. And equation B is negative 6x, oops, made that a little too big here, negative 6x minus 4y is equal to negative 28. Okay, so that was step 2, right? Step 2 was to choose a variable to eliminate. We chose x, but we could have chosen y as well. Probably would have been easier, right? And then what we did is we multiplied both equations by some number in order to get the same coefficient, in this case 6, right? Although we want one of them to be 6, we want one to be negative 6. Because our next step, step 3, says we want to add the two equations together. And by doing that, this should eliminate one, and possibly both, variables. Typically just one. So step 3 is we're going to add the equations a plus b. And again, I'm going to do this vertically because I find that easier. Right? So if we take 6x plus negative 6x, we get 0x. But 0 times x, or 0 times anything, right, is 0. Right? And then we have positive 3y plus a negative 4y, right? So 3 plus negative 4 is just negative 1 times y, right? And that's going to equal 33 plus negative 28, or 33 minus 28 is 5. Okay, so 0 minus y equals 5, or just negative y equals 5. So if negative y is 5, y has to be negative 5, right? And you can see that just by multiplying both sides by negative 1. Right? On the left side, negative 1 times negative y is positive y, and 5 times negative 1 is negative 5. So y is negative 5. Got it? All right, so we're basically halfway done, right? We're not done yet. Because remember, a solution is not a single number here. If you remember, a solution way back up here is two numbers, right? It's an x and a y. We only have the y. We now have to find x. Okay? So now how do we find x? Let's go back to one of the two original equations. We have, y equals negative 2x plus 11. Or we have 3x plus 2y equals 14. So those were the original equations. Right? Those were before I multiplied by the 3 and the negative 2. Right? So yeah, in step 4, what we essentially want to do is solve for the other variable here. So this will be my step 4 now. Right? So look, we know what y is. We know y is negative 5. Right? We found that from step 3. So all we have to do is replace y with negative 5. And we can do that either in equation A or B. It doesn't matter. Right? So let's try equation A. If y is negative 5, then negative 5 equals negative 2x plus 11. Right? So this is a single equation in only one variable. Surely you know how to solve equations like this. At least I hope you do, right? So let's just go step by step here, right? I'm going to just switch sides, right? Because I want the x on the left, right? So negative 2x plus 11 is just negative 5. And then we want to isolate the x here, right? So before we can do anything with the negative 2, let's take the positive 11 and subtract 11 from both sides. And if we subtract 11 from both sides, on the left side we're left with negative 2x, right, plus 0. And that's going to equal negative 5 plus negative 11, which is negative 16, right? So yep, you're just adding, you're adding negative 11 to both sides. You're subtracting 11 from both sides, right? So the plus 0 doesn't matter, right? This is just negative 2x equals negative 16. And now, the opposite of multiplying by negative 2 is dividing by negative 2. So divide both sides by negative 2, and that effectively cancels the negative 2. And now we're just left with 1 times x equals negative 16 divided by negative 2 is positive 8, right? Or just 8. So x equals 8, right? And y is negative 5. Now we have our solution, right? So step 5 is to write down the solution, right? And substitute this value to find the other variable. Well, so that we did already, right? So once we, step 4 was to solve the equation, and we did that here. So this was step 5. I mislabeled my steps here. Sorry about that. All right, so this was step 5. We solved for the other variable. And now in step 6, all we have to do is check, right? So start over. Step 6, we have our solution. Let's write down the solution as an ordered pair, right? It's x, then y. So even though we found y first, right, don't put the negative 5 first. The 8 goes first, and then the negative 5. So that's our solution. Okay. Right, and then step 6 is to check. Right. So let's check. Actually, we did that already. Right? If you remember, this should look familiar. The 8 negative 5, right? I originally just gave that to you. I said that that's the solution. Now we actually showed how to get that by using this process. Okay. So when we checked earlier that this is the solution, that was our step 6. So you can check again, but we did that already here. We got 2 equations that are true, so that just verifies that 8 negative 5 is the solution to this system. So we already checked, and so we know that this is correct. Okay? So that's how it goes, right? And I know this is a long process. We're going to go through several again. Once you get used to it, it's really not all that bad. But this is a good way to get you started, right? So from now on, anytime I write down an example like this, you should probably try it first, right? I would recommend you try it yourself first. And if you get stuck, well, then you go through the video and see how I do it. And again, I'm not saying that my way of doing it is the best way or the only way. There are probably other ways of doing it. For example, we eliminated x. We could have eliminated y. And I think I mentioned that it would probably be easier because the second equation we have a positive 2y. All we needed to do was make this, right, a negative 2 to cancel the positive 2. Right. So you could have done it that way too. All right, so let's look at another example now. Okay, so here's our second example. We have a system of 2 equations. Equation A is 2x plus 9y equals 2. And equation B is 5x plus 3y equals negative 8. Okay. So again, I highly recommend try this yourself right? See how far you can get. Hopefully you can get the solution. So pause the video, try it, and let's see what happens, right? Okay, so hopefully you got an answer, and let's see if we can figure this out now, right? So our step one, if you remember, is to write both equations in the form ax plus by equals c. And notice that that's done for us. They're both already in that form. So we don't have to add or subtract anything. We don't have to drag the x to the other side or anything like that, right? So step one is done for us, right? Step two is to pick a variable to eliminate. So last time we eliminated the x, right? Now I think we'll probably do better by eliminating the y here. So equation A was 2x plus 9y equals 2. And equation B is 5x plus 3y is equal to negative 8. So there it is again. I'm just copying it down. Okay, so if we want to eliminate y, what do we need to do, right? We need both coefficients to essentially match the same number, but opposite in sign. So notice that in the first equation, in equation A, the coefficient of y is 9, right? So the question is, how can we get this to be a negative 9? Right? So what number times 3 is negative 9? Some number times 3 equals negative 9, right? If you divide by 3, you get negative 3. So what we want to do is multiply the second equation here, this equation, on both sides by negative 3. Okay? So, yeah, so oops, I didn't mean to erase that. So, yeah, we'll multiply b times negative 3 here. So equation b times negative 3. So negative 3 on the left, and negative 3 on the right. Okay, so distribute the negative 3. Negative 3 times 5x is negative 15x. Negative 3 times positive 3y is negative 9y. And negative 3 times 8, negative 8. Negative 3 times negative 8 is positive 24. Okay, so that's still equation B. All we did was multiply by negative 3 on both sides. Right? And then equation A, well, notice we can leave that alone here. In fact, I probably should have wrote that on top. Yeah, so let me do that here. Make a little extra space. So equation A was, we're going to leave that alone. 2x plus 9y is equal to 2. Okay. So on to step 3. Right. What was step 3? Well, hopefully it's kind of obvious now, right? We have a positive 9y, we have a negative 9y. When we add the two equations together, right? When we add the two equations, equation A plus equation B, what do we get? We get 2x plus negative 15x is negative 13x. We get 9y plus negative 9y, which is 0y, right, or just 0. And on the right side, we get 2 plus 24. 2 plus 24 is 26. So we get negative 13x is equal to 26. Okay, so far? Right? So our step 4 is just to divide both sides by the negative 13. Right? Solve for x, divide by negative 13. Okay, so negative 13 divided by negative 13 is just 1. 1 times x is just x. And then 26 divided by negative 13 is negative 2. Okay, so, right, be careful, we're not done. Right? This is not the solution, right? Well, it's the solution to this equation. It's not the solution to the entire system, right? The entire system, you need two numbers, right? You need an x and a y. So when we write down our solution, right, we have x, then y. We know x is negative 2. We still don't know what y is, right? But that's the next step, right? That's step 5. So step 5 is to go back to any version of the equation now, right? We can use equation A or equation B. So I'll pick equation A. We have 2x plus 9y is equal to 2. But look, now we know that x is negative 2. So all I have to do is replace x with the number negative 2. And by doing that, I can solve for y. Makes sense? Negative 2 times 2 is negative 4. So negative 4 plus 9y is equal to 2. So to solve for y, we want to add the 4 to both sides. So let's add 4 to both sides. And we get negative 4 plus 4 is 0, plus 9y is equal to 2 plus 4, which is 6. Right? And if 9 times y equals 6, now we divide both sides by 9, and we get that y is 6 over 9. But remember, 6 over 9 is not in lowest terms. Right? 6 is 2 times 3, and 9 is 3 times 3. So 3 divided by 3, right, is 1. So the 3's cancel, and this reduces to 2/3. Oops, wrong color. I'm going to stick with yellow here. Hopefully it's brightest, easiest to see. So y is 2/3, right? And there we go. There's our solution, right? X is negative 2, and y is 2 over 3. Right? So we're done. That's our solution. Okay. So hopefully that's what you got. Again, there's no guarantee that the solutions, that the x and y will be nice numbers. They could be fractions, right? But typically, when they're a fraction, they'll be a nice fraction, like 2 over 3 or 1 over 4. If you get a fraction like 213 divided by 976, let's say 977, you probably did something wrong. Most of the homework problems are not going to have crazy answers like that. Okay. Okay, so that's step 5, right? Now there's also step 6 is to check. Don't forget to check, right? Because it's possible I did something wrong. It's very easy to mess up along the way here. So let's just make sure, right? So equation A is 2x plus 9y equals 2. So here's 2x plus 9y equals 2. So if I replace x with negative 2 and y with 2/3, is this correct? Does that equal 2? Right. This is equation A now, right? So 2 times negative 2 is negative 4, right? 9 times 2/3. Well, 9 times 2 is 18, right? And 18 divided by 3 is 6. So 9 times 2/3 is just 6, right? And negative 4 plus 6 is 2. So does 2 equal 2? Of course. 2 is 2. So this is true. This is correct, right? So this is a good sign, right? But be careful. That doesn't mean that we got the correct answer yet. Remember, you have to check both equations. You have to check equation A and equation B. Equation B, remember, was 5x plus 3y equals negative 8. Right? Because look, here's the possibility that if you check equation A, it works. And if we check equation B, suppose we get, 5 is equal to negative 6 or something crazy like that. Right? Then, you probably did something wrong. Right? So it's possible to work for one equation, but not both. If this is the correct solution, and it is, then both equation A and B should work. Okay, so let's take the same x equals negative 2 and y is equal to 2 over 3, plug them in, and let's see if we get negative 8 here, right? So 5 times negative 2 is negative 10. 3 times 2/3, well, 3 times 2 is 6. 6 divided by 3 is 2. So this is negative 10 plus 2 equals negative 8. And sure enough, negative 10 plus 2 is negative 8. So equation B is also correct. So now we know that this solution is correct. Sorry about that. Okay, so that's example 2. Right, let's keep going. Let's do another one. The more you practice these, the easier it'll get. Okay, example 3. So here we want to solve the equation, the system of equations, right? So the first equation is x plus y equals 11, and the second equation is y equals 2x minus 1. So again, at this point, I would pause the video, work this out yourself on pencil and paper, and see what you get. Okay, hopefully you did that. Right, so how do we do this, right? Using the method of addition, we need to get both equations into the form ax plus by equals c, the standard form or general form. And notice that the first equation is already in that form, right? You have both x and y on the left side and only the number on the right. But for equation b here, the second equation, x and y are on the wrong side, right? They're on opposite sides. So in order to get the x, the 2x, to the left side, we need to subtract it from both sides, right? So you can, oops, sorry, it should be 2x, negative 2x. So we can write this as y minus 2x is equal to negative 1. But we want to put the x first, right? So negative 2x plus y equals negative 1. So that's what goes on the left side, right? So this is still equation A. I left that alone. And equation B is negative 2x plus y equals negative 1 instead of y equals 2x minus 1. It's the same equation, just written in a slightly different way, right? Okay, so everything's lined up, right? The x's are lined up, the y's are lined up, right? So now our step 2 is simply to solve, right? Well, we're solving the system of equations, right? And step 2 is to figure out which variable you want to eliminate, x or y. And again, it doesn't matter. If you want to eliminate x, let's eliminate x. All we need to do is multiply the first equation by a positive 2 to cancel with the negative 2 in equation B. Right? So multiply. So here's equation A, x plus y equals 11. And just multiply both sides by 2. Okay, why 2? Well, to cancel the negative 2 in equation B, right? So when we do that, we get 2x plus 2y equals 22. Okay, so that's equation A. And equation B, we can leave that alone because we already have the negative 2x, and that will cancel with the positive 2x, right? So in step 3, you just add the equations, right? A plus B, or I should say equation A plus equation B, right? We get 0x plus 2y plus 1y, right? There's an invisible 1 here. 2y plus 1y is 3y. And then 22 plus negative 1, 22 minus 1 is 21, right? So now, step 4, we have 3y equals 21. Divide by 3. And that solves for y. 21 divided by 3 is 7, so y is 7. Okay? Right, so now that we know what y is, we can go back and find x, right? But I'm going to do something different, because some of you might have said, I eliminated y, I didn't eliminate x. So we can do that as well. Let's eliminate y instead. Right? So to eliminate y, notice that they already have the same coefficient. They're both 1s in the original system here. So if we add them, however, we don't eliminate the y. We get 1y plus 1y is 2y. We want to get 0y, right? So we need to simply change the sign. We need to make this, say, a negative instead of a positive. And the way to do that is to multiply both sides by negative 1. Okay, so here's equation A again. Oops. Yeah, so equation A is just x plus y equals 11. And equation B was, let's see, yeah, negative 2x plus y equals negative 1. Sorry about that. So yeah, negative 2x plus y equals negative 1. For equation B. And if we want to make this a negative sign, we have to multiply both sides by negative 1. There we go, right? So negative 1 times negative 2x is positive 2x, and negative 1 times y is negative y, and negative 1 times negative 1 is positive 1. So we get 2x minus y equals 1. Okay. So now when we add the two equations together, a plus b, we get 1x plus 2x is 3x, and y plus negative y is, well, 0y, or just 0. And on the right side, 11 plus 1 is 12. So we get 3x equals 12. Right? Step 4 is to divide by the 3 on both sides. So x divided by 3x divided by 3 is just x. 12 divided by 3 is 4. So now we get x equals 4. Okay, so you certainly didn't have to do it that way. I just did it both ways because, again, you know, some of you might have eliminated x, some of you might have eliminated y. And so by doing that, we have both solutions now. We have this, the solution for x is 4, for y is 7, so the solution is the ordered pair. Don't forget to write it as an ordered pair. This is very important, right? 4, 7. Okay, so that's the solution, right? It's not x equals 4, y equals 7. It's the ordered pair 4, 7, right? 4 comma 7. So this is supposed to be a comma here. Okay. Yeah. So if you only got x equals 4, how would you get y then? Well, you just plug in the 4 into one of the original equations. Let's say x plus y equals 11. If x is 4, right, then y is just 11 minus 4, which is 7, which we already knew, but there it is again, right? Or you could use the other equation, right? You can use the equation negative 2x plus y equals negative 1. And if you replace x with 4 again, you get negative 8 plus y equals negative 1. Add the 8 to both sides, and you get y equals negative 1 plus 8 is again 7. So, right, so it's almost impossible to mess this up. Once you get the first number, right, either for x or y, to get the other number, you just plug it in either equation. Either A or B will work. Right, so this is very versatile, right? You have a lot of choices here. And so there's a lot of different ways you could have gotten the same answer. As long as you do one of these ways, that's fine. Okay. All right. Let's do another one. Oh wait. So actually, before we do another example, so we should probably mention what this solution really represents here. The x equals 4, y equals 7. So back in your previous algebra class, you probably graphed these equations, right? These equations are linear equations, so the graphs are just straight lines, right? The graphs of these equations are just straight lines. So maybe you remember doing something like this here. Right, so here's the x-axis, here's the y-axis, and so on. Right, so the two equations, just so that I remember here, I think were x plus y equals 11. And then the other equation was, oh, how soon I forget, y equals 2x minus 1. So we'll write it in that form, the original form. So let's graph them, right? Let's see what happens. So x plus y equals 11. So the x and y intercepts are both 11. 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So way up here. And then the same thing for x, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these are 2 points on the line. All we have to do is connect those 2 points with a straight line. And yeah, that's easier said than done. This pen is not easy to graph this here. So there we go. That's close enough, I think. Okay, so that's equation A, right? Or specifically x plus y equals 11. Equation B, which I'll do in green, so notice that this is in the form y equals mx plus b. So we know b is -1, so that's the y-intercept, -1. Yeah, let's do that. Right there. And then the slope is +2. So if you remember, the slope is rise over run. So if you go up 2, you go right 1. So we're at this point. If you go up 2 again, right 1, you're at this point. So just take these steps going up, right? And then connect these dots with a straight line. So remove the clutter here. Here's 1 point. Here's another point. Here's another point. Right. No, okay. This is going to be pretty tough for me to do here. Bear with me. I'll get it eventually. Just got to do it slowly here. Okay, not perfect, but I'm not looking for perfection here. As long as it's a reasonably straight line, this is fine, right? So this is equation B, also known as y equals 2x minus 1. Okay, so notice where these 2 lines cross. The 2 lines cross at this point right here. Right? This little purple point right here. So if we look at the coordinates of that point, right, what are the coordinates of this point here? So if we go down, it looks like x is 1, 2, 3, 4. And if we go up, y is 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7. So I miscounted here. We know it has to be 7, right? So I think I drew this a little bit funny here. This should be y equals 7. All right, so yeah. So forget that part there. Yeah. Okay, so it's a little sloppy. It's a little sloppy. But the idea is that the coordinates of this point here, x equals 4, y equals 7. So that's another way we could have got the solution, right? We could graph both lines and then figure out the x and y coordinates. Obviously, you have to graph it a little more carefully than what I did here. But that should be it. Okay, so yeah, when you're finding a solution to a system, you're basically finding the one point that the 2 lines have in common, right? This one point here is the point that the 2 lines have in common. This is the point of intersection. Okay, right, but because this is really sloppy here, it's better to do it algebraically. It's better to use the method of addition. And in fact, when you do the homework, it'll specify solve by using the method of addition. So then you don't have a choice, right? You have to do it that way. Solve by the method of addition, right? Or elimination. But our book calls it the method of addition. Why? Because in step 3 here, we're adding the 2 equations together, right? When you add the 2 equations together, you eliminate one of the variables, either x or y. Okay, so I hope that helps. Now we can do another example. Okay, so here's our next example. Solve using the method of addition. The 2 equations are, so equation A, if you will, 8x minus 10y equals 5. And equation B, if you will, 12x minus 15y equals 10. Okay, so again, good time to pause the video, work this out, see what you get. Okay, so again, this one's a little bit different than the others. So if you got something a little weird or you weren't quite sure what you got, then don't worry about it, because we'll go through this step by step again, right? So step one is to write them both in their standard form. And in this case, again, they're already in their standard form. So there's nothing we have to do here. Right, ax plus by equals c. And the same thing for equation B. Okay. Well, so now we have to pick which one we want to eliminate. Do we want to eliminate the x's or the y's? Yeah, so in this case it doesn't matter. Both of them look equally difficult. So what do we need to multiply by 8 to get 12? So you can do it this way. You can say, well, this is going to be 3 over 2. But most of you probably had trouble figuring that out, right, as a fraction. So instead of doing that, you can say, well, all I have to do is multiply by the other number, right? In other words, I multiply the first equation by 12 on both sides, and then the second equation by the 8, again, on both sides. Now that gets us the same number for x. But we need the opposite number, right? So one of these is going to have to be negative. Which one is up to you? I'm going to do the top one being negative. So negative 12 instead of positive 12, right? Okay, so when we multiply negative 12 times 8x, I had to think about that for a second. Negative 96 times x. And then negative 12 times negative 10y is going to be positive 120 times y. And on the right side, 5 times negative 12 is negative 60. Right? So, okay, we get some pretty big numbers here. And they didn't have to be this big, but, you know, this is sort of maybe the quickest way to go about this, right? So all I did was multiply by the number in the other equation. So that always works. It just might not be the best way to do it, right? All right, so now for equation B, we have 8 times 12x. That's going to be positive 96x. 96x. Let me try that again. Right. And then 8 times negative 15y is going to be negative 120 times y. And then 10 times 8 is 80. So when you add the two equations, we should eliminate x. We get 0, right? So this is our step 3 already. A plus b, equation A plus equation B, right, is going to be 0x plus 0y equals 20, right? Negative 60 plus 80 is 20. Right? So 0 plus 0 is 0. We get 0 equals 20. Well, wait a minute. 0 is not 20. This equation is false, right? This is not true. So you might wonder, did I do something wrong? Maybe I multiplied wrong, or maybe I added wrong or something. So that's a possibility here, but you go through this again, and I don't think I did anything wrong here. Let me just check. 15 times 8 is negative 120. So I didn't do anything wrong, but I got this really improper equation, right? 0 does not equal 20. Yeah, oops, sorry. 0 is certainly not equal to 20. Okay. So what went wrong here, right? So it turns out if you were to graph both of these equations, and I don't think I'm going to do it very carefully here, right? But you're going to end up with something like this. So equation A might look something like this, right? And then equation B, if you graph that line will look something like this. And notice that the two lines don't cross anywhere. Right? The two lines are parallel. Parallel lines do not meet. They do not intersect. Right? So there is no point of intersection. And as we just saw in the previous example, when we did graph the lines, somewhat sloppy there, right? We did get a point of intersection. So we got a solution, right? The point of intersection is the solution. And if there's no point of intersection, there is no solution. Okay? So that's the answer to the problem, right? When you get two numbers that are not equal like this, right, you can stop right there and say, look, if that happens, then there is no solution. And we're done. Okay? Right? The two lines are parallel. They don't meet. They don't intersect. And so there's no solution. Okay? And you would have gotten a similar equation if you tried to eliminate y instead of x. Right? You can eliminate y by multiplying the first equation by 15 and the second equation by, say, -10. Okay? So that's how this works, right? Now, going back to step 2 here, we didn't have to multiply the first equation by -12 and the second equation by 8. We could use smaller numbers, right? Like 3 and 2. So we could have used -3 here and +2 here. And we would have gotten smaller numbers, nicer numbers. Okay, so just be aware of that. If you did it that way, that's fine. You got smaller equations, but you still got something like 0 is equal to 3 or something, right? And if 0 is not equal to 3, same result, no solution. Okay, so that is a possibility, that the system simply has no solution. Okay, and in that case, we call such a system, right? This is an inconsistent system. An inconsistent system has no solution. Okay, so it doesn't happen often, but some of the problems in the homework will be inconsistent, and the answer will be no solution. So just be aware of that. Okay, I think one last example for this section. So again, here's another system of equations. We want to solve it. So this is equation A is x equals 3 minus 2y. And equation B is 5x plus 10y equals 15. So step 1, we need to get the x's and y's on the same side, right? And in equation A, we're going to have to add the 2y to both sides. So if we do that, we get x plus 2y equals 3, right? And so equation B, we can, well, essentially leave that alone because it's already in the standard form. Okay, so step 2 is to multiply, well, which variable do we want to eliminate, x or y? So to me, it looks like x is easy because in equation B, we already have +5. In equation A, we just need a -5. So all we have to do is multiply the first equation by -5. Again, on both sides. Oops, so there should be 3 in yellow. Right? So again, this is equation A, equation A. So when we do that, we get -5x minus 10y is equal to -15. And equation B, we can leave that alone, right? So this is still equation A. Equation B is now +5x plus 10y is equal to 15. So in step 3, we're going to add the equations together, A plus B. So -5x plus 5x is 0. -10y plus 10y is also 0. And -15 plus 15 is, well, 0. So notice we eliminated basically everything here. We get 0 equals 0. So what does that mean? Well, 0 does equal 0, right? This is true. This equation is true. No matter what x and y are, this equation will always end up being true. So what does that mean? No solution? Actually, it's quite the opposite. In this case, we have an infinite number of solutions. Right? Everything on this line is a solution. Okay, so if we were to graph these two lines, line A and B, so here's line A. What was it originally? It was x equals 3 minus 2y. Right. And let's see, that equation will look something like this. So we know when y is 0, x is 3. And let's say y is 1, then x will just be 3 minus 2 is 1, right? So 1, 1. So line A looks something like this. Okay. Now, if we graph line B is 5x plus 10y equals 15. And if you graph that line, you get this. Yep, same exact line, right? So line A and line B are identical. These are identical lines. Okay. Now, when you go back to the original system here, when you go back to the original system, they don't look the same, right? They look different, right? So they're two different equations, but they represent the same line. So notice what happens, right? If all I did was multiply the first equation by 5 on both sides, I end up with equation B. So yeah, we did negative 5 to cancel the x's and y's, but yeah, it's the same equation, right? You can just multiply the first equation by 5, get the second equation, and so they are identical lines. And so what that means is every point on this line is a solution. And there's infinitely many points, so there's infinitely many solutions. So how can we write? Well, we can't list all the solutions because it'll take forever, right? But we can say that, right, given a specific x, you can find y, or given a specific y, you can find x. So for example, if you know what y is, x is just 3 minus 2y. Right? So this is for any number y. Or if you want to go the other way, if you want to solve for, say, y in terms of x. So this is equation A again. You can do that, right? Subtract the 3 from both sides. Negative 2y is going to be x minus 3. Now if you divide by negative 2, you get that y is negative 1/2 x plus 3 over 2. Right. So now you can list all the solutions as follows, right? Given an x, y has to be negative 1/2 x plus 3 over 2. Right? So one example, right? One such solution is when x is 0, y is 3 over 2. And that point is right about here. That's the y-intercept. Okay. Another solution would be when, let's say, y is 0, and x is going to be 3. So that's this point right here. Right? So those are the intercepts, but there's many, many other points. So for example, let's suppose x is 12. What would y be? So y is going to be negative 1/2 times 12 plus 3 over 2. So that's going to be negative 6 plus 3 over 2, which is, sorry for squeezing this in here, it's negative 12 over 2 plus 3 over 2 is 9 over 2. Okay. Or, sorry, negative 9 over 2. Negative 9 over 2. Okay. So here's another solution, right? And the point is they just go on forever. You can list these forever. Just different x's, you get different y's. So yeah, So you can write the solution either this way or this way. But there isn't just a single solution. There's infinitely many solutions, right? So that's the third possibility, right? Either the two lines are identical, they're the same line, or the two lines are parallel, in which case there's no solution. Or what happens in most cases, of course, is that when you graph one line and then you graph the other line, they meet at precisely only one point. And when that happens, you get a unique solution, one unique point. But a unique point, remember, is two numbers, right? It's an x and a y. So the 5 and 7 is just my example, right? This could be any x and y here, right? All right, well, I hope that helps, right? Solve systems of equations. And again, this is by using the method of addition, the method of addition or elimination, right? But then there's also another method called substitution. And maybe some of you are familiar with that. Substitution, if I can spell it right. And any one of these examples we did, you could have also used the method of substitution, and you would have gotten the same result, the same answer, which is either, you know, a unique solution, or it's infinitely many solutions, or it's no solution. But you would have gotten the same result no matter which method you chose. So if you want to use the method of substitution, go right ahead, right? But if it says specifically to use the addition method and you use the substitution method, you're going to lose points for that, right? Don't expect to get full credit if you don't follow the directions. So pay very clear attention to the directions here, right? And especially in this case, it says to solve using the method of addition. And we did that here, right? Okay. Yeah, so maybe I'll do one example using substitution, but just bear in mind that it's not required that you know substitution. It comes in handy in some very simple cases. Okay, one last example. I think I lost count. I don't know if this is example 6 or 7. Either way, right, so we want to solve this system of equations here. 1/3 x plus 1/4 y is equal to 7 over 6. And the second equation is 3 over 2x minus 1 over 3y is equal to 7 over 3. Okay, so this looks harder, right? Because nobody likes fractions, I'm guessing. Unfortunately, in some cases, we just have to deal with them. And in this case, we're given coefficients that are fractions. They don't have to be nice whole numbers every time. Okay, so whichever method you choose, the method of addition or elimination, or the method of substitution, the first thing I would do is essentially eliminate all the fractions, right? Clear the denominators. Right? If you don't like fractions, get rid of the fractions, right? So how do we do that, right? Let's look at equation A first. Equation A is 1 over 3 times x plus 1 over 4 times y is equal to 7 over 6. So the denominators are 3, 4, and 6. Right. So what's the least common denominator out of 3, 4, and 6? The least common denominator is 12. I hope you can see that, right? So how did I get 12? Well, like you could do 3 times 4, and 3 times 4 is 12. But that's not always going to work, right? The idea is that 12 is sort of the least common multiple of all these numbers. If I write the multiples of 3, 3, 6, 9, 12, 15, 18, and so on, and I write the multiples of 4, right? 4, 8, 12, 16, 20, and so on. And then the multiples of 6 are 6, 12, 18, 24, and so on. So when you look at all these lists, the number that's the same on both lists, well, there's a lot of them, but the first number that's the same on both lists, on all 3 lists, is the number 12. So that's our least common multiple, and that's our least common denominator. Okay, we're going to get into this when we get to chapter 7, So we're going to talk about least common denominator again, and in fact thinking of it a little bit differently. But for now, this is all we need.